So for today, products. You all know the rules about multiplication, and the rules that they give you there on page 27 basically say if you multiply something by 0, the answer is 0. If you multiply something by a -1 and it started out positive, it basically flips the sign. Okay, those are the multiplicative properties. Bottom of page 27 is the variety of rules associated with any of the multiplication that you do. Okay? That's all in there for you. And you could utilize those. Let's, in a nutshell, look at example 1. Now, your book examples are yours to use at your leisure. Here's my example 1s for you. Example 1, just to kind of get us started, we're going to start with the following. Okay, there's a couple different ways you can do this. You can multiply it in order, if you wish, or you can consider grouping them, negatives and positives, if you wish. It doesn't really matter. I will say this, if there are an even number of negative numbers, the result's going to be positive. If there are an odd number of negative numbers, the result's going to be even. So am I right to say the answer is going to be a positive? I would say so. All right. So depending upon how you want to play it, 3 times 2 is 6, 6 times 1 is 6, 6 times 4 is 24, and 24 times 5 is 120, right? You could have grouped them if you wish, okay, all your negatives together. But any way you do it, you would have come up with the same result. Remember, you do not have to write the positive in front of a number. It's understood that if a number is positive, if a number doesn't have a sign, that it's positive. That is just simply understood. All right. Here's the next one I want to do for you. So this is going to be my example B. So it's going to be okay. Would you say the answer is going to be positive or negative here? Negative, I agree. I would highly recommend moving stuff around because if you notice, you have a fraction and then you have its reciprocal, albeit a positive versus a negative. So whenever you have a fraction, look for a way to eliminate that fraction by combining it with something that has the same multiple. Okay, so if this were a 12, if this were an 18, no matter what, it would help to eliminate this fraction. Whereas if you go from left to right, it's going to be a heaping pile of a pain until you get to here. All right, so I am going to say, let's move this that way. Okay, and that result of -1/6 times a +6 gets rid of the fraction. That should be a 1. Okay? Then the rest of it is going to equal a -8, right? So be on the lookout for those fractions. And that's their example B. You could do that one however you like. I like to move stuff around. Make it easier on yourself. If you put this times that, so now you got +4/6 times 2. It's too much work. Move around and cross cancel where you can.
Ashley and Harwood to the gym, please.
Okay, and final example. Final example. This is where the multiplicative property of 0 comes in. Here's my example. There's mine. Now, in no universe should any of you have to even give a thought to any of this. It doesn't matter if I have 27 non-zero numbers being multiplied together. Since there's a zero in this entire phrase, the answer is going to be a zero. So be on the lookout for that. If there is a zero, stop. Just the answer is zero. When you multiply anything by zero, the result is zero. Okay? And that is what the gray boxes below that set in example 1 tell us. Okay? Example 2. Oh no! More proofs. Don't worry. We're going to be leaving proofs before you know it. It's just a few things that we have to cover to give you your knowledge, okay? Just to give you a taste of this stuff. Example 2. Please look at it. If we start with what they say, negative AB is the same thing as negative 1 multiplied by A multiplied by B, we know this to be true because the product of this has been made negative because there are three things. You might not think of A and B as negative or as two separate things, but it is. There are three things. One of them is negative. So the multiplicative property of negative 1 has caused this to happen. Okay? And they now, in the next step, you might think again, okay, this is silly, but you have to see it this way. I can choose to group my negative 1 with my A. That's a B. I can choose to group these two together. Associative property. Okay? By doing this, I can say the identity, the multiplicative property, again, takes us back here, even though it's kind of like the identity property, but with a negative. Now, this has become negative. Yeah, multiplicative property of negative 1 has taken us back there. And therefore, that's what this last bit is. Negative AB is the same thing as saying negative A times B. Or, and this isn't in your book, they could have said A times negative B. Now you all know this transitive property. This is the same as this. Okay? You all know this. You all do it. You just don't name it. And I know that's not very fun. You're already doing it. You just don't name it. Okay? Today you don't actually even have any proofs, but I still wanted you to be introduced to it. Moving on to examples 3 and 4. Okay, can I flip this? Almost. Okay. Examples 3 and 4, top of page 29. So it gives you variables now. Okay, it doesn't change anything. Nothing here has been changed. All it's doing, my friends, is adding a little bit of flavor to the party. So here's example 2. First one I have for you is going to be negative 5r multiplied by negative 2s. This is my example A. Multiplied by negative 6. Okay? You can do this one of two ways. You can multiply all the numbers together and then multiply all the letters together. Or you can realize that this is saying negative 5 times r times negative 2 times s times negative 6. And you can choose to commute and associate like with like. Okay, what do I mean by that? Well, I am going to move and associate all in one fell swoop. I'm going to commute and associate my numbers and my letters together. Okay? 5 times 2 times 6. Is that going to be a negative or a positive? 5 times 2 times 6. Negative. Negative 60. Right? R times S is simply R times S. If you want to just leave it as is and then work it by going is 60, is RS, I don't care how you do it, as long as you end up with the same answer. The book shows you on their example A, commuting and associating where necessary. So, I mean, whatever works for you. I like this method. B. Okay, their example B is just a little bit bigger, and it gives two separate things being combined. Okay? I don't actually have another example B. So I am going to do this one. Here we go. This one, I have this one. Okay, so the product of this added to the product of that. Work each piece separately. Negative AB times negative AB is what? Positive AB, good. And whether or not you list that, obviously you don't need to. Being added to, I can move this around so that I've grouped like with like. 6, negative 1 times A times B. Remember, AB is just A times B. All right? 6 times negative 1 is a negative 6AB. Okay? If you were to do your odds and look in the back of the book, it's not going to be written like this. It would be written like this. Okay? Are we done though, you think? No, very good. If they listed it like this, they'd be wrong. ABs are the same thing. A positive 1AB combined with a negative 6AB is a negative 5AB. Okay? Watch out for that, because that is going to be in there, I guarantee it. Now, if these things were different, like if this was ABC and that was AB, you could not combine them. Okay? But since these are the same thing, make sure you combine them where necessary. Collecting like terms. All right, that's 3. 4 has you working something even a bit more difficult, but to me, once you get this far, it's just a matter of practicing. So here's 4. My A looks like this. My A is actually a little too, yeah, I can use that one. Okay, so negative 3/4 multiplied by a negative 28 t squared plus 12. Okay, you guys are going to think I'm weird. Well, I know you already do. But I left a big space here so that you could recognize that each of those pieces has to be distributed into. In other words, you can't combine these because they're not like terms, so you have to multiply this by this and add it to whatever the product of that and that is. So I'm going to show that what it would look like. Negative 3/4 multiplied by negative 28 over 1, and I'm going to just ignore the t squared, leave it separated because it'll just make it easier for me to see these numbers. Added to negative 3/4 multiplied by 12 over 1. Okay? So far so good? Both of these is divisible by 4. So positive 4 into a negative 28 is a negative 7. A positive 4 into a positive 12 is a positive 3. So negative times negative, did y'all come up with 21? 21t squared, and a negative times a positive. I'm just going to change it to a -9. I think you guys are able to do that without me entertaining you. Okay? These two cannot be combined. Why not? Are they the same thing? Nope. Nope, nope, nope. T squareds and numbers don't get along. Okay, that's A. Here's their example B, or my version of their example B. Okay, this is my version of their example B. Okay, this is my version of their example B. This 18x is just going to sit here and hang out, and he's going to watch what happens here and here. Because this 4, this -4, precedes both of these items, you must distribute. -4 by 2x, -4 by -3. What's -4 times 2x, class? Thank you. -4 by -3. Awesome. 18x has now shown up. It's late to the party, but better late than never. Are we done? Combine your x's. 10x plus 12. Can you combine that? No, sir. That's example 4. Example 5 is yet another proof. You're going to go ahead and read it. I keep saying this. You're already doing these things. You just don't name them. Okay? Let me give you another example of proofs.